In this video, we consider some examples on how we can apply these Lagrange multipliers to find the maximum and minimum values of some function subject to the constraint. Okay, so let us consider these two examples. Okay, so example number one. Okay, so this one will be example number one. Okay, let's consider this one as example number two. Okay, first let us start with the example number one. Okay, to find such of maximum and minimum values of this function, okay, subject to some constraint, we may apply the Lagrange multiplier. So the Lagrange multiplier, okay, let's be consider LM. Okay, LM here meaning that Lagrange multiplier. So Lagrange multiplier here, so we have a such of form, okay, such of representation, which is the gradient of f should be equals to lambda, okay, times with the gradient of g. Okay, so from here we need to find, okay, so we need to find all the solution for our lambda x, y, z. Okay, so after we find all the solution for our lambda x, y, z, that satisfy this Lagrange multiplier. So from this value we will find the maximum and minimum values of our function. Okay, so first example, okay, so we want to find the maximum values of this function fxy is equals to 3x minus 6y subject to the constraint 4x squared plus 2y squared equals to 25. Okay, so the first thing what we need to do is we need to know our function, okay, which is f here. So we need to know what is our fxy. So this fxy here should be 3x minus 6y. Okay, and then we need to know what is our gxy. Okay, so since our function here, we have a function with two variables, so therefore we need to have a gxy. To have a gxy, we need to have some condition here, okay, to find the gxy here. Okay, so meaning that we need to have a such of form that gxy here should be minus equals to 0. Okay, to define our gxy, we need to have some condition that gxy here should be equals to 0. Okay, so meaning that, okay, this part I think I forgot to mention about this gxy in my introduction video. So therefore I just want to add this information. To define our gxy, we need to have a condition that gxy here is equals to 0. So meaning that from our constraint, okay, if you see from our constraint, we have something like 4x squared plus 2y squared equals to 25. So from here we can just rewrite. Okay, so you can just rewrite 4x squared plus 2y squared minus 25 equals to 0. Okay, from our constraint. So therefore from here we can just define our gxy here as 4x squared plus 2y squared minus 25. Okay, because I just want to repeat once again. To define a gxy, we need to have a such of condition that our gxy here should be equals to 0. Okay, so therefore from our constraint we can just rewrite such like this 4x squared plus 2y squared minus 25 equals to 0. So it follows that our gxy here equals to 4x squared plus 2y squared minus 25. Okay, and then we come to the second step. Okay, so now for the second step we need to find, okay, or we need to consider such of Lagrange multiplier. Okay, So this is a Lagrange multiplier and we need to find, okay, we need to find all the terms here. Okay, so from here, okay, what's the meaning of gradient of f? Gradient of f here, I can write this one as delta f, okay, delta x, okay, delta f, delta y, okay, sorry, okay, because it's a vector, and then equals to lambda. So now we have a delta g, delta x, delta g, delta y. Okay, okay, lambda here is just a constant, it's just a value. Okay, so this one, what is a delta f, delta x? So this will be equals to 3. Okay, and then this one will be minus 6. Okay, and then so lambda, okay, delta g, delta x will be 8x. Okay, and then so from here we have a 4y. Okay, we have a 4y. Okay, so from here it follows that we have 3 minus 6 is equals to, okay, so since our lambda here is just a some number, okay, some value, it's just a constant, so therefore I can write this one as 8 lambda x 4 lambda y. Okay, so from here, okay, okay, so from this Lagrange multiplier we come to this part. Okay, we find all the terms and then we put into our Lagrange multiplier, so we have this one. Okay, okay, so okay, now, okay, okay, so from this part, okay, after we already put all the terms in our Lagrange multiplier, okay, what we need to do, the third step here, okay, the third step here, we need to find all the solution. Okay, find all the solutions for lambda x and y, okay, that satisfy, okay, that satisfy step number 2. Okay, okay, step number 2, which means that should be satisfy this Lagrange multiplier. Okay, okay, so from here, okay, from the second step here, we can say that, okay, since we have a vector, so this 3 and this minus 6, okay, this 3 will be considered as a I component and this minus 6 will be considered as a j component. This lambda, this at lambda x will be considered as a I component. This 4 lambda y will be considered the j component. Okay, okay, so therefore when we see from these two vectors, of course the I component should be equal each other and j component should be equal each other. Okay, so therefore from here I can write that from the second step, we know that this 3 is equals to 8 lambda x and minus 6 is equals to 4 lambda y. Okay, because it is because vector, okay, because of vector, so therefore the I component should be equal each other and for j component should be equal each other. Okay, so because of that, from the step number 2 we can say that 3 is equals to 8 lambda x and minus 6 equals to 4 lambda y. Okay, okay, so from here, okay, now so somehow we have a set of two equation. Okay, which the first equation here, we have a lambda and x and okay, sekejap saya tunjuk lah. Okay, this equation we have only lambda and x, and this equation we have a lambda and y. Okay, so therefore we don't need to use the we don't need to solve using persamaan serentak. Okay, because from this equation they only have x, okay, lambda x and lambda y. Okay, okay, so from here we know that from this one I can write something like, okay, so from here x here is equals to 3 over 8 lambda, and from here I can write y here is equals to minus 6 over 4 lambda. Okay, okay, so we have our x here equals to 3 over 8 lambda, and y here equals to minus 6 over 4 lambda. Okay, okay, so now we have our x is equals to 3 over 8 lambda, which means we have a x in terms of lambda, and then y here we have minus 6 over 4. Okay, so this one is just a minus 3 over 2 lambda. Okay, so we have a y here in terms of lambda. Okay, okay, so now from the third step, what we need to do, we need to find all the solution for this lambda xy that satisfy the step number 2. Okay, our Lagrange multiplier. Okay, so from here how we can find such of lambda x and y here. Okay, okay, we know that our constraint, okay, from our constraint, okay, so we have from our constraint we have something like this one, right? Okay, 4x squared plus, okay, 2y squared is equals to 25. Okay, okay, so we need to consider this constraint. Okay, why? Because the important thing when we consider the Lagrange multiplier, actually we just want to find the maximum and minimum value along this constraint. Okay, along the constraint. So therefore our x and y, okay, our x and y should be, okay, this x and y, okay, this x and y should be in this constraint. Okay, we only consider such of point x and y here within this constraint. Okay, so therefore if from here we know that our x here equals to 3 over 8 lambda, y here equals to minus 6 over 4 lambda. So we can just substitute, okay, our 4, okay, so now we have 3 over, okay, 8 lambda squared plus 2 minus 6 over, okay, sorry, this one already, minus 3 over 2 lambda squared is equals to 25. Okay, okay, so from here we have 4 9 over 64 lambda squared plus 2, okay, so 2 9 and then plus 4 lambda squared. Okay, sekejap ni, betul tak? Okay, betul, 4 lambda squared equals to 25. Okay, okay, and then from here we can just find our lambda lah. Okay, from here we can just find our lambda. So how we can find our lambda? So we have something like 36 over 64 and then plus okay, and then plus so this one will be okay, 9 over 2 lah. Okay, so this one will be 9 over 2 and then equals to 25 lambda squared. Okay, okay, so from here, okay, so from here okay, I can just times with 32, right? Okay, so this one I can just times with 32. Okay, I can just times with 32. Okay, and then I will have okay, so from here 32 64, okay, 64, okay, 36 32, okay, 32 times 9 8 1 288, okay, and then tambah 36 4 1 12 1 3 2 4. Okay, 3 2 4. Okay, so we have 3 2 4. Okay, 3 2 4. Okay, and then okay, 3 to 4 is equals to 25 lambda squared. Okay. Okay, 3 to 4 over 64. Okay, boleh ni tak? Boleh apa? 6 4 8. Okay, so we have a sekejap, tengok sekejap, boleh tak bagi? Tak boleh. Okay, so this one will be apa ni? 5 per 1 bahagi 0 point. Okay, so should be okay. So from here, okay, have something like 5 point, mana ni? 5.0625 is equals to 25 lambda squared. Okay. Okay, so from here we can just find lah. Okay, what will be our lambda squared? Okay, lambda squared here is equals to, okay, 5.0. Okay, lepas tu kita bahagikan dengan 25. Okay, so we can have such value here. Okay, 0.2 mana ni? 2025. Okay, so we have a 0.2025. So if we want to find the lambda, so since we have a lambda squared, so meaning that we need to have a positive minus. Okay, we need to have a positive minus. So to have a positive minus, we need to take the square root of this one. Okay, square root of 0. Okay. 0.2 mana ni? 2025. 2025. Okay, so we have this number lah. Okay, plus minus 0.45. Okay. Okay, so this will be the value of our lambda. So we have a such a value of lambda. We have two values of lambda, which is the first one will be minus 0.45, and the second will be 0.45. Okay. Okay, so we already found the values of our lambda, so it's not difficult for us to find the values of our x and y. Okay, so from here, okay, so we say that okay, so if my lambda here is equals to minus 0.45, okay, then x will be equals to, okay, berapa tadi? X will be equals to 3 over 8. Okay, so minus 0.45. Okay, and then for our y is equals to minus 3 over 2. Okay, and then we need to times with minus 0.45. Okay, so this one is equals to what? Okay, so we have a mana ni? Okay, so we have a 3. Okay, and then 8. Okay, 8 times, okay, minus 0.45. Okay. Okay, so we have this number lah. Okay, negative 0. Okay, negative 0.8333. Okay, and so on lah. Okay. Okay, and then for y, okay, for y, okay, for y we have minus 3. Okay, minus 3, and then mana ni? Over 2 darab Okay, minus 0.45. Okay, and then okay, so we have this number 3.3333. Okay, so this one will be equals to 3.3333. Okay, okay, so this is will be the first solution. Okay, if our lambda here is equals to minus 0.45, then it follows that we have our x is equals to negative 0.833, and our y here is equals to 3.3333. Okay, and then the second solution, now we have our lambda is equals to 0.45. Okay, so if our lambda is equals to 0.45, then our x here will be equals to 3 over 8, 0.45. So from here it follows that this one will be 0.8333. Okay, and then the y here will be equals to minus over 3 over 2. Okay, 0.45. So from here we have 3.3333. Okay, so it's one. Okay, so this will be the second solution. Okay, if our lambda equals to 0.45, then our x here equals to 0.833, and then our y here will be equals to 3.33333. Okay, okay, so we have only two solutions. Okay, for our lambda x and y. Okay, that satisfy this Lagrange multiplier. Okay, from the second step. Okay, okay, so now we come to the step. Okay, last step, step number 4. Okay, this will be the step number 4. So the step number 4, we just need to find all values of function, okay, fxy, okay, at this point. Okay, find all the values of our function, okay, for all solutions. Okay, for all solutions. Okay, so we have these two solution. Okay, so now we have the first value. Okay, so the first value will be f minus 0.8333 and 3.3333. Okay, so we choose this solution first. Okay, xy. Okay, and then okay, so let's find the value here. Okay, let's find this value. Okay, so now we have our fxy is equals to 3x minus 6y. Okay, so 3 times minus 0.8333, and then minus 6, 3.3333. Okay, and then what were the values here? Okay, 3x minus 6y. Okay, and from this one, 3 minus 0, minus 0.8333. Okay, and then minus 6. Okay, so minus 6, 3.333. Okay, okay, so we have this value. Okay, we have this value, which is a minus 22 point. Okay, okay, somehow minus 22.5. Okay, near to this number. Okay, and then this one. Okay, so we need to find the values of our function at this point. So we have 0.8333, and then we have 3.3333. Sekejap, yang ni ada minus sorry. This one we have minus. Okay, so we have minus here. So from here we have 3 times 0.8333 333, okay, and then minus 6 minus 3.3333, okay. So from here, okay, so we have this value, okay, should be 17.5, okay, should be 17.5, okay, this one, okay, so we have this value, okay. Okay, so from the step number 4, we already find all the values of our function for all solution that we already found, okay, from the third step. Okay, so now we come to the last step. Okay, we come to the last step. So the last step, we just need to see. Okay, so the last step. Okay, so the last step, just choose the largest value to be maximum and smallest value to be minimum. Okay, so from the step number 4, okay, so it shows that this value, which is a f0.8333 and minus 3.3333, okay, is equals to 17.5, right? Okay, 17.5. Okay, so this value, okay, this value will be the maximum value of our function, okay. And then if we have, okay, this value, okay, the value of this function, the value of function at this point, okay, so we already calculate this one will be equals to minus 20.5. Okay, this value will be minimum value, okay, minimum value, okay. So 17.5 will be the maximum values of our function subject to this constraint, and minus 22.5 will be the minimum values of our function subject to our constraint, okay. Okay, so this is how we can this first example, we just want to discuss on how we can apply the Lagrange multiplier to find the maximum and minimum values of our function subject to some constraint. Okay, so this will be the first example. Okay. Okay, okay, let's consider the second example. Okay, let's just consider the second example. Okay, so now we have a such of question that we need to find the maximum and minimum value of this function subject to this constraint. Okay, okay, so let's repeat, okay, what we already did from the first example. So we have 5 steps. Okay, from here we have a 5 step. The step number 1, okay, we need to know our function and also our function and also our g lah. Okay, our g. Okay, so now we have our function fxyz, which is equals to xyz. Okay, and then the second, we need to find our gxyz. Okay, so now we have gxyz because we have our function here which depend on 3 variables. So we need to have a such of condition that gxyz here should be equals to 0. Okay, to define our gxyz, we need to have this condition. So from here it follows that our x squared plus 2y squared plus 4z squared minus 24 is equals to 0. So from here it follows that our g xyz will be equals to x squared plus 2y squared plus 4z squared minus 24. Okay, so we have this one. Okay. Okay, and then the second step, what we need to do, we just apply our Lagrange multiplier. Okay, so the Lagrange multiplier meaning that we need to have this one. So we have delta f, delta x, okay, delta f, delta y, okay, delta f, delta z. Okay, so this one will be lambda, delta g, delta x, delta g, delta y, okay, delta g, delta z. Okay, so this one. Okay. Okay, so let find all the terms here. Okay, so from here, delta f, delta x. So this one will be equals to what? This one will be equals to yz. And then delta f, delta y will be equals to xz. And then delta f, delta z will be equals to xy. Okay, and then this one lambda. Okay, what will be delta? Okay, what will be delta delta g, delta x here? So this one will be equals to 2x. Okay, and then this delta g, delta y will be equals to 4y. Okay, we take from this part. Okay, and then delta g, delta z will be equals to 8z. Okay, so this one. Okay, okay, so from here it follows that we have such of this delta yz, okay, is equals to yz, xz, xy is equals to 2 lambda x, 4 lambda y, 8 lambda z. Okay, so this one. Okay. Okay. Okay, so from here, okay, we have this one. Okay, so now okay, and then okay, so this will be the second step. Okay. Okay, so from the third step, okay, what we need to do is we need to find all the solution. Okay, we need to find all the solution. Find all the solutions. Okay, find all the solution for our lambda, x, y, and z that satisfy. Okay, satisfy step number 2. Okay, so from here. Okay. Okay, so from here it follows that. Okay, so from here it follows that we need to compare. Okay, we need to compare because we have a vector. So for I component, we need to compare with the I component. J component, we need to compare with J component. And Z component, we need to compare with Z component. Okay, so from here it follows that we have this one. Okay, we have this one. So we have yz is equals to 2 lambda x. Okay, and okay, and okay, next we have xz. Okay, we have xz. Sorry, we have a xz is equals to 4 lambda y. Okay, 4 lambda y. And lastly, we have a xy is equals to, so it's equals to this one. Okay, it's equals to 8 lambda z. Okay, so this one. Okay, we just need to compare for the I component and I component, okay, J components and also K component. Okay, okay. So now, okay, we need to find all the solution that satisfy number 2. Okay, that satisfy number 2. Okay, so how we can do this one? Okay, so let's start from here. Since we have some kind of x, y, z, okay, for each equation here we have x, y, z, and also we have a lambda. Okay. So what we can do, okay, let's look for this one first. Okay, so from here we know that we can just have our x here. So x here is equals to what? Okay, so from here my x here, I can write my x here is equals to from here my x here equals to y z over 2 lambda. Okay, so from here I have my x here equals to yz over 2 lambda. Okay, so it follows that from here, okay, we can have something like yz. Okay, we have something like yz is equals over 2 lambda, okay, times z is equals to 4 lambda y. Okay, so from here, I have this one. Okay, and then okay, from here I have something like yz equals to 2 lambda equals to z here. Okay, so y I can cancel this one. Okay, y I can cancel. Okay, and then so from here I have something like what here? Okay, so from here I have something like z squared. Okay, z squared is equals to 8. Okay, so I have a z squared is equals to 8 lambda squared. Okay, 8 lambda squared. Okay, 8 lambda squared. Okay, so z squared is equals to 8 lambda squared. It follows that, okay, so from here z squared equals to 8 lambda squared, so I have my z here should be equals to plus minus, okay, sekejap. Okay, z is equals to plus minus square root of 8 lambda. Okay, square root of 8 lambda. Okay, so this one. Okay, ataupun macam ni lah. Okay, so from here, since I have some kind of squared here, okay, some kind of squared here, so I have something like this squared. So I can say that my z here is equals to square root of 8 lambda. Okay, square root of 8 lambda. Okay, square root of 8 lambda. Okay, so now we have z here is equals to square root of 8 lambda. Okay, square root of 8 lambda. Okay. Okay, so this will be the first one. Okay, so this z, our z here equals to square root of 8 lambda. Okay, next what we can do is, okay, we try to find, okay, we try to substitute our x here from this one. Okay, from x equals to yz over 2 lambda to this xy equals to 8 lambda z, sorry. Okay, so now we have okay, so now we have this one. Okay, xy is equals to 8 lambda z. Okay, so we know that our x here equals to what? Our x here will be equals to yz. Okay, and then over 2 lambda, and then y is equals to 8 lambda z. Okay, so we can just cancel our z here. Okay, so now we have something like y squared is equals to 16. Okay, 16 lambda squared. Okay, so from here so I can write something like this one. Okay, y squared here is equals to 4 lambda squared. Okay, so from here it follows that my y here is equals to 2 lambda. Okay, 2 lambda. Okay, sebab kita boleh ni lah. Okay, we can just compare. Okay, y here with this one 4 lambda, so therefore I have y here equals to 2 lambda. Okay, Okay, so now I have my z here equals to square root of 8 lambda and my y here equals to 2 lambda. So from here it follows that, okay, so we can just find our x, since our x here is equals to y z over 2 lambda. Okay, so y here, okay, y is equals to lambda, and then my z here equals to square root of 8 lambda, okay, and then over with this 2 lambda. So in the end, my x here will be equals to square root of 8 lambda. Okay, okay, so now we have our x here equals to square root of 8 lambda, y is equals to 2 lambda, and my z here is equals to square root of 8 lambda. Okay, okay, so next what we need to do, okay, so now we have our constraint. Okay, so we have our constraint here, x squared plus 2y squared, okay, plus 4z squared equals to 24. Okay, equals to 24. Okay, so this one. Okay, so from here we just substitute our x. Okay, our x here will be what? Our x here will be square root of 8 lambda squared, and then plus 2 lambda squared, and then plus 4 z tadi will be square root of 8, okay, lambda squared is equals to 24. Okay, and then from here we can find our lambda. Okay, since we have 8 lambda squared plus okay, 8 lambda squared plus 8 lambda squared, and then plus 32. Okay, 32 lambda squared equals to 24. Okay, so from here I have 16 plus 32. 16 plus 32 will be 48. Okay, 48 lambda squared equals to 24. Okay, so from here I will have my lambda squared here is equals to 1 over 2. So our lambda here we have two values, which is a plus minus 1 over square root of 2. Okay, okay, so this will be the so we will already find the values of our lambda, okay, from our constraint. After we substitute our x, y and z, so our lambda here will be equals to plus minus 1 over square root of 2. Okay, so after we already found our lambda here is equals to plus minus 1 over square root 2, so it's not difficult to find our x, y, z. Okay, so okay, so now we have a, okay, if lambda is equals to minus 1 over square root of 2, okay, then we have our x, y, z, okay, where x tadi berapa? X tadi is a square root of 8 lambda, okay, and then our y here will be 2 lambda, and z here will be square root of 8 lambda. Okay, so we just substitute our lambda here by square root of 8, okay, 1 over square root of 2. Okay, so this one will be 2 times 1 over square root of 2, and then this one will be square root of 8, okay, 1 over square root of 2. Okay, so this one will be equals to what? Okay, so this one will be equals to okay, so this one will be minus 2. Okay, this one will be minus 2 over square root of 2, and then this one will be minus 2. Okay, so now we have a condition. If our lambda here equals to minus 1 over square root of 2, then the value of our x, y, z will be given by this. Okay, x equals to minus 2, and then we have y here equals to minus 2 over square root of 2, and then z here will be equals to minus 2. Okay, okay, so next, okay, so next we need to find if our lambda, okay, if our lambda is equals to 1 over square root of 2, okay, then we have our x here equals to square root of 8 lambda, y is equals to 2 lambda, z equals to square root of 8 lambda. Okay. Okay, so from here we have a square root of 8, 1 over square root of 2, so this one square 2, 1 over square root of 2, and then this one will be square root of 8. Okay, 1 over square root of 2, so this one will be equals to 2. This one will be 2 over square root of 2, and then this one will be 2. Okay. Okay, so if our lambda here equals to 1 over square root of 2, then we have this condition, we have such of solution. Okay, so our x here equals to 2, our y here equals to 2 over square root of 2, and then our z here is equals to 2. Okay. Okay, so this will be the step number 3. Okay, step number 3. Okay. Okay, and then step number 4, what we need to do is we need to find all the values of all the values of our function f(x,y,z) at all solution. Okay, at all solutions. Okay, so meaning that we need to find the values of our function f minus 2. Okay, minus 2 over square root of 2, and then minus 2. And then the second one, we need to find our function here at 2 over square root of 2, and then 2. Okay, so this one will be equals to what? Okay, so since we have x, y, z, so this one is minus 2 over square root of 2, and then we need 2 times with minus 2. So this one will be 4. Okay, and then we have minus 8. Okay, minus 8 over square root of 2. Okay, and then this one will be 2 over square root of 2, and then 2. So this one will be 8 over square root of 2. Okay. Okay, and then the last step, the number 5. Okay, so the largest value. Okay, the largest value will be our maximum value, and the smallest value will be the minimum value. So it shows that from this one, f minus 2 over square root of 2 minus 2, which is equals to minus 8 over square root of 2. Okay, so this value, since this value is the smallest, so this one will be the minimum value. Okay, minimum value of our function. And if we have f2 over square root of 2, 2 is equals to 8 over square root of 2. Okay, so it follows that this one will be the maximum value. Okay. Okay, so this is how we can apply the Lagrange multiplier to find the maximum and minimum value of our function subject to some constraint. Okay. Okay, so I think enough for these 2 examples. Okay, later maybe you can try to do try to do the some exercise that I already upload in the iTalim by yourself by repeating these 5 steps. Okay, on how we can find the maximum and minimum value of our function subject to given constraint using Lagrange multiplier. Okay. Okay, that's all. Thank you.